Hey folks, so today we're going to talk about something called Git and GitHub, but first let's kind of set the stage with a couple quick concepts. So we spent the last couple lessons saying that we had a personal computer or a personal machine. We also said that there was this other place called the server. So imagine this is one Linux or Unix device. This is another Unix or Linux device. And we said that we could communicate from the PC to the server with a program called SSH. So here's where we kind of got stuck though, because we liked the idea that we could use programs like Nano in both of these places to make files and create them in both of these separate places. But here's where we kind of run into some problems. It would be really, really nice if we could write code on our local machine, where we pretty much have all of our tools and can customize things to our heart's content, but then we want maybe it to end up on the server, because the server is kind of the only place where we can actually have other people interact with our code. So how do we do that? Well, we could kind of imagine that we do everything over the SSH connection, but there's another option which is really, really convenient across the software development world. And that's a place called GitHub, or a forge if you want to skim through some of the terminology. So the other workflow that we have is that we can write some code on our machine, we can send it to GitHub, and then we can send it from GitHub to the server. The reason we're able to do that is because there's one more tool that is installed in all three of these places. On our personal computer, we have a program called Git. On the server, we also have a program called Git. And you might imagine, GitHub also has a program called Git. So the difference between Git and GitHub is that Git is a program, or a CLI program, command line interface, kind of like all the other Linux commands we've been working. And GitHub is a location for storing something called repos, or GitHub repositories. So this is going to be a location where we can store all of our code and interact with it from both our computers and on the server. So I'm going to draw a big horizontal line. And the way that I first want you to see this is, let's imagine we just have a single file at some point in time. So I'll add some text right here. And let's say that this file is called the README. Now let's say that this is some kind of really important thing, and we want to start tracking all of the changes inside of this document. So maybe we invoke something called git and create the initial commit. Which you can think of as kind of the initial copy or the initial version of our document. Now let's imagine maybe we make some changes to the README. So let's imagine that we maybe add a title up here to the top. So I'll add a really big block, and maybe that modifies some of the stuff inside of the file. Well, it's still a README, but we've made some changes. What did we change? Well, we added a title. Let's think of this as creating a new commit where we say that we add the title. So in the previous version, we just had the README. Now we have this README with a title in it. Now let's say we make another change. We still have the README. But let's imagine that maybe we add some kind of author block right here. It's still the README, but now we have created another point. We have added the authors. So in total, this is the essence of Git. We have files, maybe we have some files and folders on our system, and then at each point in time, we are creating these snapshots of our files to keep track of what we did at a certain time, and, in fact, why did we do it? So this accomplishes two ideas. The first is the idea of a commit. And I want you to think of a commit as a snapshot of our code at a specific point in time, and that every commit is accompanied by and a message is why we made the commit, or rather, what changed at each point in time. As for the relationship between Git and this other thing, which we called GitHub, GitHub is a place for storing these changes. So we can make some of these changes on our actual machine, but eventually think of it like we share these changes up to GitHub. And while we're at it, I think I'll show you kind of a finished result of what some of these pieces look like. So one of the examples is actually the book that you've probably been working on through i211 so far. The infra book, which is this thing deployed out here on a website, is actually all built out of a GitHub repository. So see how there's this interface over here on GitHub, and you see that there's some files inside of here. There's this thing called a .git attributes, a .gitignore, a .git modules, a just file, a license, a readme, a book.toml, and all this other stuff inside of it. Well, I have a repository out here on GitHub, and then if I open my terminal and maybe do a couple commands, such as first, notice nothing in my home directory. But if I were to run git clone git at github.iu.edu :info-infra-book.git 321, it says that it's cloning something into my machine. It's receiving a bunch of objects. And now if I do ls, I have a new directory called info-infra-book. If I cd into that directory, there's, well, a Git repository. So let's scroll down. Let's click this button that says view code. We said that there was something called readme. There was something called book.toml over here. And sure enough, we have book.toml, and we also have readme.md right here. So the cool thing about Git and GitHub is that we can look at all of these files, make changes on our local machine, but then we can eventually share them back up to GitHub. Okay, so definitely follow along with me here. I'm just going to go back to github.iu.edu. I'm going to zoom out just a tiny bit so it's easier to see. And do you see how there's this thing that says create new up here? Let's see. So there's this box up here that kind of looks like this little plus icon, and it says create new. I'm going to click that. I'm going to say the thing, which says create a new repository. That's going to take me to this interface where it can say choose an owner. So I'm going to choose myself. I'm going to create a repository called scratch space. Hopefully it's available. I'm going to give it a little description. Just kidding. Let's say let's practice working with Git and GitHub. I'm going to go ahead and make this public. It doesn't really matter if you make it public or private. The nice thing if it is public is that then your instructors can help you out with it. I am going to check this box that says initialize with a readme. And okay, I think that's pretty much going to be good. So I'm going to pause just a moment here, draw your attention one more time to the important things. So owner, in my case, it's Hazel. It's going to be your username for the other part. Scratch space is kind of how I like to name this for a moment. Description, set a description. I made mine public, and I definitely did need to check this box that said add a readme. So I'm going to pause here one more second while you hopefully follow along with me on this. Okay, 3, 2, 1, clicking the big button that says create repository. Okay, so now we have this repository out here on GitHub, and we see that it contains a single file called readme.md. So I'm actually going to practice just kind of making some changes right here. So let's do that one more time. I clicked this readme. That took me to this interface where I could actually see things. Now there's a button right here, which kind of looks like this little pencil, which I'm going to click, and that's going to take me into this thing where I can actually edit the file in real time, preview the changes. So let's just make some modifications. Let's practice working with Git and GitHub. Right now, I am working through GitHub's web app interface, ! And I can preview that to see what that change looks like in real time. But, ooh, there's that new vocab word. Let's zoom in and focus on this real quick. So there's something that says commit changes, and it says that there is, well, 2 boxes. Let's give some names to these things. This first line is going to be called something called the commit message. So this is where we write our first set of commit message portions. And then this thing right here is actually called the extended message block. I actually don't know if there's a perfect name for it. And then there's a couple options down here. In i211, you're mostly going to stick with something like that because we're going to do something called mainline development where you're always working on the main branch. And finally, there's this confirmation box that says actually commit the changes. So let's say that I wanted to add some stuff to the README. I'm going to add an emoji here because emoji make things more fun. Sparkles emoji. And let's say add an important line about how we're working on GitHub. Oh, pro tip, great commit summaries contain fewer than 50 characters. Okay, so let's make this message a little bit more terse. Let's say add a line about how we're working on GitHub. That's much more terse. Okay, let's commit that change. Cool. And now we've made a new commit. Let's do that one more time. I'm going to go back to this edit button, click the edit button, and say goals. So my goals right now is 1, I want to practice creating changes through GitHub. Then I want to practice creating and pushing from the command line. Okay, we're going to go back through that one more time. I've updated the README. I'm going to add a sparkles emoji again and say add some goals for what I want to accomplish. Commit on the main branch. Let's commit those changes. And we have a new version of our README created. So now I'm going to go back to the scratch space directory, which a few ways you can do this. The way I tend to prefer is that there's something called a breadcrumb here at the top where it says Hazel and scratch space. So I'm going to click on scratch space, which takes me back to the repository itself. And now I actually want to look at something. So do you see how there's this icon right here that says that, well, we just now created some changes and there's a total of 3. 3 what? Well, let's click and find out. Okay, cool. So this is the set of every commit that we've ever made. So remember how I said earlier when we were doing some of that introductory material, we can look at every individual piece of code in our history. So here was the initial commit. If I click this thing that says browse the repository at this point in history, I'm effectively going back in time and I can see what the README looked like at the first state. I could look at the second version. And now we have, oh yeah, right now I'm working through GitHub's web app interface. I can click this one. Okay, cool. Here is the README with all of our most recent up-to-date changes. If I click this set of the breadcrumbs again, I'm back at the base of the repository and I can see the most recent up-to-date version of our code. Let's see one more thing before we move on. So there's this thing up here called the Insights tab. I'm going to click the Insights tab. I'm going to click the network view. And do you remember how I was being kind of strange earlier and showing you all those bubbles next to each other? Well, this is the real-time visualization of that. So in the same way that we could look at our code by looking through the history manually, there is a visualization called the network graph, which shows me the initial commit, followed by add a line about how we're working on GitHub, followed by add some goals for what we want to accomplish today. Okay, so now how do we actually work from GitHub onto our local machine? So to do that, I'm going to look back at the book, and today we're working on this chapter, Forges, Git and GitHub, and let's start kind of looking through, trying to figure out what are we trying to do today. Okay, cool. So now we're ready to start working through some of this material. I'm going to follow this kind of in a semi-structured way, but this is definitely really, really important. So let's do a little bit of setup. So there's a few commands we have to run. The first is this git config global user.name. I'm going to copy the first part of that. And then it says right here that I have to swap out this thing for your username with my username. So for me, that's going to be Hazel. I'm going to do the next one, git config -- global user.email. This is going to be my hazel@iu.edu email. Enter on that. The remaining 3, we can pretty much just copy and paste as is. So default branch name. This is for some historical reasons. Nano, because Nano is the text editor of choice we were kind of working with for a bit. And finally, do we want to do rebased polls? No, we don't. So quick side note. So maybe some of these won't really make sense, but this is really just setting the stage for some things that will be much better defaults for us going later. So with that setup out of the way, let's take a look back over at this repository on GitHub. So there's a few ways you can do this. The way I like to do it is I just kind of put my cursor in the address bar up here, do Control-C to copy, and then back here, let's do an ls, just confirm that maybe we're in somewhere that we can work for a little bit. I'm going to say git clone. So clone is our first git command, git and clone, and then I'm going to right click to paste that address inside of here. Sometimes it takes me a few attempts to get my address right there, but notice now if I do ls, I have something called scratch space. And if I cd into scratch space and maybe cat out the readme, notice that the contents of this readme right here, all this stuff you see, is exactly the same as what we have over on GitHub. So let's clear this out and talk about what some of the next couple steps are going to look like. So I want you to think about 3 different subcommands. The first one is going to be git add period. The next is going to be something called git commit. And then the final one is going to be called git push. So remember we said that the period is a representation of everything in the current directory. We said that a commit is taking a snapshot of our code. And we said that there's this method that we can use to push our changes from our local machine up to GitHub. So just for now, focus on what are these 3 commands and how do we actually use them to make changes on our local machine and send them up to GitHub. So let's see this in action. Let's say we touch a new file called maybe file1.txt. If we do git status, see how there's this thing that says untracked files, file1.txt is red. Well, let's use that first command, git add dot, git status. Oh, cool. Well, we changed from red to green. It says that there is changes to be committed, which is a new file called file1.txt. So let's say git commit -m for message, and say add new file1.txt. Close out that. So let's draw attention to one thing real quick. We are making a commit, giving it a message. Inside of the message, we are using this quote, and inside the quotes, we're describing what we did. So now when I click enter, ooh, something happened. It gave me a little bit of feedback saying that I'm on the main branch. I added a new file called file1.txt. One file was changed. It created something called file1.txt. If I say git status one more time, it says that my branch, not quite sure what a branch is, but that's okay, is ahead of origin main. Origin main, okay. Let's break this down a little bit further. So origin main, think of that as saying what is over on GitHub. How far ahead am I compared to GitHub? Well, I'm ahead by 1 commit. There is one thing on my personal machine that is not available yet on GitHub. Oh, but by the way, you can use git push to publish your local changes. So let's see what happens when we do that. Let's do git push. It's going to ask me to authenticate. So what happens when I refresh the page on GitHub? Well, I can find out. Oh, look at that. There was a new change about 1 minute ago, and that 3 went from a 3 to a 4. So if we look back at the history, in addition to the things that we were doing in GitHub's interface directly, we now have this thing that says add new file1.txt. Awesome. So now we have a workflow that basically allows us to add files locally and send them up to GitHub. But let's kind of slow down a little bit further. So clear the screen. And I said that there was kind of this magic set of commands where we do git add period, git commit -m with some kind of message in between, and then we do git push in order to send these things back up to GitHub. So let's talk about what is actually being accomplished in each of these steps to try to understand the steps a little bit better. So I think I made a visualization back out here in the book that I'm going to kind of jump down to real quick. Yeah, okay, so here it is. In GitHub, or excuse me, within Git, there are kind of these 3 places. So let me zoom in on these real quick to just focus in on this. So there's a few places. There's this thing called the working tree. There's this thing called the staging area, and there's this thing called the local repository. When we do git add is putting some of our files or any of the changes into something called the staging area. Think of the stage kind of like this location where we're getting ready to make our commits or getting ready to create snapshots of our code. It's only when we actually do the commit that actually writes this to the local repository. And you can kind of repeat this process as many times as you want. You can make some changes to your files, you can add them to the staging area, then you commit, which adds them to the local repository, and scroll down a little bit, It's only when you actually do a push that actually sends things from your local repository up to the remote repository on GitHub. So let's do that, and let's just get some more practice. So this is a scratch space. There's really no way that you can actually mess things up, so just try it out. See what happens. I'm going to create file2.txt. I'm going to create file3.txt. If I do git status, well, I said a second ago that when we do git status after creating two different files, it's going to tell us that there are two new files that have not been added to our history. Wait, what does that mean? It means that these files are unstaged. They don't really belong anywhere. How do we stage files? Question mark. How do we stage files? What's that phrase again? Okay, well, we said that is a commit. So I bet if we first add the two files to our staging area and then commit, that will add them to our local repository. So let's test that hypothesis. So if I do git add period, git status, okay, cool. Both of these have been changed. Both of these are ready to be committed. So let's try that out. Let's do git commit -m, add two new files. Okay, we've added two files into our local history. If we do git status again, it's going to tell us that our branch, our local branch, is ahead of origin main by one commit. That's just because we haven't pushed yet, and maybe we're not ready to push. Let's talk about the staging area just a little bit more. So I say git status. That's gonna be exactly the same. Let's clear the screen. Let's say ls just to confirm that we have file 1, file 2, and file 3. Nothing is ready to commit. Let's just keep doing this. So let's touch file4.txt. Let's touch file5.txt. Git status. And again, there's two files, file4, file5.txt, which according to Git are both not being tracked. So, well, what if we put one of them into the staging area? So let's get a little crazy. Let's git add file5.txt, then do git status. Okay, let's look for some of our vocab words. So, changes to be committed. Okay, so here's where we see something about the word stage, and we can do some stuff to unstage this, but maybe we don't really care about unstaging. So what happens if we make a commit where file 5 is green and file 4 is red, file 5 is green? If we run commit, what do we expect to happen? Well, let's find out. This is the great thing about computers. We can just kind of try and see what happens. So I'm going to say git commit -m add file5.txt. Let's do git status and confirm we are ahead of origin main by 2 commits. That means there are 2 things on our local machine that are not currently shared up to GitHub, and it still says that file 4 is untracked. So here's another question for you. Let's clear the screen, say git status one more time. So we have a bunch of files, file 1, 2, 3, 4, 5, on our local machine. Question for the audience. If I were to git push, will file4.txt show up on GitHub? What do you think? Well, again, computers are great because we can just kind of find out. So let's go ahead and push. Well, it took me 2 attempts to get my password right, but again, we said ls, and on our local machine, we have 4 files, 1, 2, 3, 4, 5. If we refresh on GitHub, is this what you expected? So we have 5 files on our local machine, but we said that one of those files was not being tracked. Therefore, file4.txt is not on GitHub between file 4 and file 5. So here's that key difference between the staging area, the local changes, and the remote changes. It's only when we explicitly say git add file4.txt, git commit -m, add file 4, git push. It's only when we add everything to our local repository, then push up to GitHub, that those changes show up in GitHub. So now we've proven to ourselves that we can make changes, create files, and then push them up to GitHub. We haven't really answered how do we actually make changes inside of the files? So let's talk about that for a little while. I'm going to clear the screen, and I'm going to maybe edit this readme.md simply because that's the place where we have been making some changes so far. So I'm going to open up the readme inside of Nano, and I'm going to say, have we accomplished certain goals? So let's just add some text inside of here. Practice adding text to files and committing them. So in Nano, we're going to write out, enter, Control X to exit. And when we do git status, oh, well, something else has happened. So now we had a previous version of README, but Git has detected that the readme.md has been modified. So let's go through that workflow again. Or actually, let's kind of see what did we change. So one more command. What if we do git diff readme.md? So a diff in computing is the idea of we have the difference between 2 points in time. So if we say git diff readme, git diff readme, what we're asking is what is the difference between the modified version of readme and the previous version that exists out here on GitHub. Let's do enter. And we see that there's this little plus sign and this green text that says we now have an extra line where we practice adding text to files and committing them. So let's Q to quit out of that, and let's go through that stage commit workflow. So let's add the readme.md to our staging area. Let's say git status, confirm that we went from the red version into the green version. So now we're ready to say git commit-m, add a new goal to readme.md. Cool. So now I bet if we push things up to GitHub and refresh the page back over here, we now have that third goal in the README. Okay, so that kind of covers actually the core operations of Git. So let's kind of start testing our knowledge out here. In fact, let's kind of see what have we talked about and what have we not talked about. Let's kind of test your knowledge on some of these things. So we talked about the staging area. The staging area is where your files go before you commit them or take a snapshot. We maybe have some intuition that the remote repository is something that is slightly different from our local repository on our personal machines. We don't quite know what the Git directory is. We don't quite know what the .gitignore. We said that git status is a way to figure out what files have been changed. We said that a diff or difference is the difference between the current state of our files and the previous version. We said git add file is a way to add things to our staging area. Commit is actually taking a snapshot. We didn't talk about this. We didn't talk about this. We said that push is a way to publish. And we said that clone was a way to initially get the files from GitHub to our local machine. So let's talk real quick about some of these other things as we kind of wrap up for today. And I think git remote is probably going to be the easiest one, and git pull and git remote kind of go together. So what happens if I do git remote -v? Well, that tells me that there's this special place called origin, and I think you heard me use the word a couple times, but there's this special place called origin, or origin/main, which is a representation of our repository on GitHub. So git remote -v is simply confirming to me that there is this extra place that is not my local machine out on github.iu.edu, Hazel scratch space. So pull, I think, might be a little bit intuitive. If we think of the push, if we think of push kind of being like an upload, what do we think pull might be? Well, if push is upload, I bet we can think of pull being kind of like download. So let's kind of confirm, refresh the page, see that everything, we have 8 commits out here. If we do git pull, well, what does git pull tell us? Git pull says that we are already up to date. We are already up to date with everything that is going on GitHub. So if there are 8 commits out here on GitHub, pull is just going to confirm that everything that we have on our local machine is the same as our remote machine. But maybe if this isn't true, so let's go to README. Let me edit this real quick. And say, are we able to pull changes from GitHub to our local machine? let's add a commit message, say add another line about pulling from GitHub, GitHub to local. Oh, add another line, add a line about pulling from GitHub to local, commit directly on the main branch. Let's commit those changes. Okay, well, we now have some changes in this README, step 4, but I bet we don't have that line on our local machine. So this just says 3. Oh no, oh no, oh no, panic, panic, panic. It says 4 right here. We don't have a 4 right here. Oh no, how do we get code from GitHub to our local machine? Okay, well, we kind of had the answer already. What happens if we git pull? Okay, so a couple things happened right there. We said git pull, we authenticated, and then a couple steps happened. It said that we are pulling from this thing called main onto origin main, and then it did something called fast forwarding. What is fast forwarding? We don't quite have time to get into that, but the important part is that readme.md had 2 changes, 1 addition indicated by this plus sign and 1 deletion indicated by this minus sign. Now, if we cat out the readme.md, we see that indeed our files are now in sync with one another. There is a 4th line on our local machine, and there's a 4th line on the remote machine. So what's next? We said that let's see, so where have we not covered? We haven't covered the .git directory, we haven't covered the gitignore, and we haven't covered this thing called tagging. So let's cover these 2 things real quick. So we said a moment ago that there's this thing called the local repository, but maybe we're curious, how does Git actually keep track of all this stuff? It's a little bit beyond the scope of what we want to accomplish right here, but if I were to do ls-a to reveal every file inside of here, there is a special directory called the .git folder. Now the contents and how the .git directory works is way beyond the scope of what we can cover in this course, but I want you to think of the .git folder kind of like being a local database. So .git is a local database that communicates and manages file changes. So I'm going to wave my hands here a little bit and say that something happens. We don't really maybe know exactly how Git works, but something is being updated on our computer to keep track of all these changes. Gitignore, though, is a little bit more interesting, and this is going to be really useful for some of the things we talk about later in the class. So let's imagine that I have this really, really dangerous file called passwords.txt, and do we really want passwords.txt? So let's say that I'm editing this, and for some reason I am typing my passwords in this file. In this file, my Facebook password is this seems like such a bad idea. So, but you know, sometimes this is necessary. So what is the gitignore? Okay, well, let's break it down into its constituent parts. We have the word git and we have the word ignore. If we have the word git and the word ignore, what do we think the gitignore does? Well, let's create it and find out. So if we touch the .gitignore, and what happens if we start editing the gitignore? So maybe nano.gitignore. Well, we said there are certain files that would be extremely problematic to track. So the .gitignore file is a way to tell Git what it should not track. Ignore, in other words. So if I put passwords.txt inside of here, write out Control-O, enter Control-X to exit, what happens if I do git status now? Oh, okay, hold on. Let's see, what is the difference between these 2 points in time? So before, when we did git status, but we did not have the gitignore, it said that passwords.txt was part of our list of untracked files. after we modified the gitignore and put the passwords.txt as a line inside of it, now it says that the gitignore is not tracked, but notice that we don't see something like passwords.txt right here. So the cool thing about the gitignore is that it tells Git what it should not track. So let's do git add.gitignore, git status changes from red to green. Let's do git commit-m, add an emoji because emoji are fun. Let's do the see no evil monkey. Okay, so git commit-m, see no evil monkey, add.gitignore, close out the quote, enter, git push. And when we take a look back out here on GitHub, go back to the base. So we now have a file called gitignore. We have all of our other files, but importantly, we do not have the passwords file. So the passwords file is super, super secret, and we do not want just anyone in the world to be able to read our code and know what our passwords are. So it is set up so it is not tracked by GitHub. No one should be able to read our code and figure out what our password is. Okay, so I think we've covered just about everything. Let's talk about this very last thing, which is called a tag. Okay, and let's clear out the screen and kind of talk about this at a high level for just a moment. So I'm going to go and start adding some things. So a lot of people seem to be kind of, I don't know, intuitively aware that there are these things called version numbers. Like maybe you've been looking at something and someone talks about like the version 1.0 release, or maybe the version 1.0.1 release, or the version 2.1.0 release, or the v1.0.5. So a version number breaks down a release into three concepts. Usually under semantic versioning, this first thing is going to be known as the major release. This next number is going to be known as the minor release. And this very last thing is going to be called the patch number. Patch number. So tagging is a way to represent these things. So if you get to a certain point in your development and you want to create a version of your code or a release of your code, you will assign a new number to it and a message about what that intends to accomplish. So let's say that our code in its current state, we're pretty confident in its state, so now we're ready to make a release. Briefly, I don't want to get too far into like the intricacies of how versions work, but usually if you're following a semantic versioning workflow, 0.1.0 might be an initial state where you're just saying that I'm kind of figuring some stuff out. Maybe after a little bit, you can say 0.1.1 if you make a patch to that, 0.1.2 if you're making a small change to that. And maybe you'll keep working on that for a little while until you're really confident that your code is ready for just anyone else in the world to work with. This is usually called the 1.0 release, and there's conventions around it, but usually when you create the version 1 release, that's a way to tell other people that your code is stable and you will not break the code by making backwards incompatible changes after some point. It's a little bit beyond the scope of what we talk about in this course. For the most part, we are going to tell you where to make your changes and like what your numbers should roughly be, but it's good to be vaguely aware of these. So I'm going to create the 0.1.0 release, and I can do that with git tag-a v0.1.0. Let's give it a message and say initial release v0.1-0. Okay, so before I click enter, let's break this down. So we're using the git tag command. We're tagging it at version 0.1.0. And we're giving it a message kind of the same way we create commit messages, where we say initial release v0.1.0. Okay, 3, 2, 1, enter. Oh, so what happened? Kind of doesn't look like anything happened. But if we say git log, notice that at this point in time, there is now this additional thing called a tag. So the state of our code where we add a gitignore now has this thing called the v0.1.0 tag, and that is currently up to date with origin main and it's currently up to date with where our local repository is. So let's quit out of that, and let's do a slightly different version of the push. So let's do git push -u origin v0.1.0. Enter. Okay, so what happened? Well, we used a variation on that push command, git push-u origin v0.1.0, and GitHub responded to us by saying that we've created a new tag called v0.1.0. So what happens if we refresh GitHub? Oh, well, maybe we have some intuition already. We said that we are creating a new release using this tag method, and maybe our eyes are kind of drawn to this side of the screen. So here's what I bet. I bet when we refresh the page in this section that is talking about releases, I bet we're going to see something like v0.1.0 right here with a tag to our code. So let's see if that hypothesis is correct. I'm going to click inside of GitHub, click the refresh button. Oh, and sure enough, there's this new thing called a tag. So what happens when we click on this tag? Click. Ah, there's the v0.1.0 release. So let's do some quick pattern matching. We said that we were creating an initial release v0.1.0, and it looks like that is also reflected over on GitHub now. So at this point, we've basically covered our full Git workflow, and really all of the subcommands that we need to think about in order to understand how to use Git pretty effectively for the purposes of this course. So let's do a really quick review and talk about what our day-to-day workflow is going to look like when we use Git. So I'm going to refresh basically everything. I'm going to actually remove this scratch space directory and kind of start from scratch on everything. So when we are working with Git, we're probably going to cd to some location or move into some appropriate directory. So maybe we're actually working inside of i211, maybe we have some kind of homework set, and maybe we first want to go into the homework before we start working. After we've already cloned a repository, so let's just kind of refresh that again. My repository was Hazel, so github.iu.edu. That one I was working on was called Scratch Space. Then once I cd into Scratch Space, I'm now inside of it. Optionally, we could make sure our repository is up to date, but we just cloned it, so it kind of by definition should be. Our next idea is that we want to be able to open this in Visual Studio Code, which we're going to talk about a lot more kind of starting next week. So Visual Studio Code contains all of our files, but now it is mirrored such that the file system on our computer is pretty much exactly the same as the one that we currently see here. Oops. Cool. So the file system on our computer is pretty much exactly the one that we see out here. The next couple steps is we're going to go through that add commit push workflow. So let's do it one more time just to get comfortable. So let's do file6.txt, git status. See that we have an untracked file, git add period, git status, git, yep, it's in our staging directory, it's in our stage. Let's do git commit-m, add one more file called file6.txt, and git push that back up to GitHub. And as we said, to round it out, at some point, we probably will want to tag our repository at certain points in time, but for the most part, we'll kind of tell you when and where to do some of those pieces. So now let's talk about some next steps. We pretty much have all the concepts that we're going to use for GitHub in this. Here's a couple things that I think would be a good idea right now. Let's try. So let's try adding more files. Let's try making changes in those files. And let's try pushing those changes to GitHub. So this is a scratch space directory. There's really no way that you can make mistakes inside of here because it's a scratch space. It's just a place for you to get comfortable working at Git at the command line and then pushing it back up to GitHub. Because this is a tool that we're going to be using over and over and over again through the rest of the semester and possibly for the rest of your career. So it's best to get comfortable with some of these pieces now.